have a phase change diagram. This is a diagram showing how the phases have changed as we add heat, energy, thermal energy, which is heat. So we're looking at the relationship between the thermal energy, which is heat, and temperature, which is really a measurement of the kinetic energy. So if we start off as a solid, we're at the solid phase where the atoms are just vibrating in place. Okay. As I increase the energy now, I'm going this way, I'm increasing the thermal energy, I'm increasing the heat. What happens? Temperature is going to go up. This is the temperature goes up until it gets to what's called a melting point. And this is specific to different chemicals. They'll have specific points at which they melt. Like the like melting point of water would be 0 degrees Celsius. It's also the freezing point, because if you go the reverse, it would be the point at which the chemical freezes. So here we have, we're going this direction though. We're going to add heat, so we're going to have melting. So now we're at a liquid, and I increase more heat, so more energy, thermal energy, and now we see the temperature goes up. But notice, during the actual phase change, no change in temperature. So the temperature's here, it's not changing. Remember, temperature's on the y-axis, so it's staying the same. You'll notice, during each phase change, temperature stays the same. So now I've got a liquid, and I add more thermal energy, S. So now, liquid, here we have vaporization forming a gas. During vaporization, there's actually no change in temperature, but now we're at a gas. And I increase more heat, so more thermal energy. Temperature now goes up until you get to a point where ionization can happen. So it's so hot that the atoms lose their electrons. So during that phase change, there's no change in temperature. Ionization. So ionization is a process going from a gas to a plasma. And now at a plasma, I increase the thermal energy, temperature keeps going up. All right, now the opposite, if I go the other direction, so let's say we're at a plasma. Okay, so now I'm going this way. I'm going to decrease the thermal energy until we get to a phase change, where the plasma is going to convert to a gas. So it's going to get its electrons back. They've escaped. Now they're coming back in the process called recombination. During this process, no change in temperature. Notice. Now it's a gas. We're cooling it off. We're still cooling, so we're decreasing the thermal energy or heat. As we decrease, gas also decreases in temperature. Temperature is going down in the gas until it gets to the point where the gas is going to convert into a liquid in the process called condensation. So condensation, this is what happens like in rain, clouds. So rain is formed through the process of condensation from the gas and clouds. All right, so condensation, during this phase change, no change in temperature. All right, now we decrease the heat, cool it off even more. Now it's a liquid, but it can decrease in temperature until you get to the freezing point at which the chemical would freeze. In other words, it's going to form a solid. But during that phase change, no change in temperature. Now we're at a solid. We decrease the amount of heat. In other words, it gets cooler. Temperature goes down. So this just represents changes of phases and the relationship in the energy, the heat, which is thermal energy, and the temperature. So remember, temperature is a measurement of the kinetic energy of the atoms, how much they're moving. They're moving a lot, higher temperature. They're not moving, there's vibrating place, lower temperature. When you look at a thermometer and you're trying to get your temperature, you're feeling sick, you feel like you got a fever. All right, the thermometer, you used to have mercury in the thermometer, but now it's just alcohol. It's dyed red so you can see it. So that what you're seeing is alcohol, the level in the thermometer. If you think about it, the atoms in this state where they're low kinetic energy, taking your temperature because you feel like you have a fever, in that thermometer has alcohol in it. It used to be mercury, now it's alcohol, it's ethanol, which is dyed red so you can see it. So it's made of atoms, the alcohol. So those atoms, when it's hot, they move more. Okay, so when it's not hot, they don't move as much. And when they move more, they spread out more. So we're back down. You can see these are kind of packed tight. So it's lower in the thermometer, the level's lower, because all those atoms can be packed together tight. They're just vibrating in place, they're not that hot. I mean, the temperature's low. But if the temperature goes up, they have more space. They start spreading out a little more. Spread out. Higher temperature. Increase kinetic energy. If it's even hotter than that, they're going to spread it even more. So that's why that thermometer rises. It goes higher the hotter it is. And even though technically you're not looking at phase changes, you're not in the thermometer, it's still liquid. It's not going from solid, liquid, gas. Still though, in the liquid itself, as it heats up, the atoms can move more. So if a hotter liquid, the atoms would be moving more than a liquid that is cooler. So technically they're still liquid, they're still moving, but there's ranges of motion. And that relates to the temperature. So a very, very hot liquid, the atoms will be moving much more than a cold liquid. So that's what's happening in the thermometer. It's just the atoms are moving more when it's hotter. So when they move more, they spread out. There needs more space. That causes that thermometer to rise. It causes that red liquid, which is alcohol, which is made of atoms. They're spreading out. So they're moving up the thermometer. That indicates a higher temperature. If it's cooler, they're not moving as much. They're packing down, even though they're still liquid. I mean, they're moving, but they're packed down. So the volume is decreased. So the thermometer then goes down. The level of the alcohol is lower, so it's a lower temperature. So that just shows you temperature, kinetic energy, same thing. Well, temperature is a measurement of kinetic energy of the atoms.